everyone. In this video, we're going to be talking about computer fundamentals. So I'm going to introduce some key terms and concepts that have to do with computers, and a lot of these I'm going to be referencing throughout the rest of this class. So you can consider this a sort of video glossary of all the terms that you'll need to know just with regards to using computers. So without further ado, let's start learning about computers. So what I want to do first is I want to answer the question, what actually is a computer? So a lot of machines out there, a lot of the old-fashioned ones at least, are made to perform exactly one task. So if you think of like more of an old-fashioned type of factory, if you used to watch how it's made back in the day, you might remember all those different machines that do one thing, like, hey, here's the machine that puts labels on the soda bottles, and then here's the machine that screws the lids onto the soda bottles, and here's the machine that packages all the soda bottles up, wraps them up in plastic and sends them on their way, right? A lot of machines, a lot of the old-fashioned types of machines are designed to perform exactly one task, and they perform that task typically pretty well if they're designed well. Another example of one of these old-fashioned types of machines is like one of the really, really old typewriters where you push down on a certain key and that moves a lever that actually puts the letter directly onto the paper. Every key corresponds to exactly one lever, and it's the physical action of your finger pressing down on that lever that actually, puts the letter on the paper. Computers, on the other hand, what separates computers from these types of machines are that they can be programmed to do many tasks. So, the idea of computers originally were that they were designed to perform these mathematically complex operations. So back in World War II, that's when we really saw a boom in computing technology, because we realized that, hey, if we can build these machines that are really good at calculating, let's say, artillery, the angle at which your artillery cannon needs to be angled at, and the velocity at which the bullet needs to be fired at in order to take down, a plane or a tank or something like that. If we can have a machine that can actually do those calculations and then send the resulting outputs, the resulting calculated values to the people who are actually controlling the artillery, then we can have, really precise artillery strikes. So what they did was they made machines that essentially they're programmed to take in certain values, like the speed of the wind, the location of whatever target relative to the location of the artillery. They would take in all these pieces of data and then perform the calculation, and then they could give those resulting pieces to the people who were actually controlling the artillery. And that really was the basis of what a computer was, is you're giving it different pieces of information, and it was able to do many different types of calculations. You weren't just building a machine that did one calculation over and over and over again. You could have it do many different types of calculations. And then we expanded on this idea to the point where we could actually start having it do multiple things. So instead of just the artillery calculations, we could have it, say, also do calculations for sales tax, and also do physics calculations for falling items, and also do, et cetera, et cetera, et cetera. Essentially, we got to the point where we could start writing our own programs so that a computer could take in that program and then take in whatever user input and run that program with that user input, and so on and so forth. Well, we'll get into some of these ideas a little bit more. I don't want to get into too much technical detail, but the point where we're at right now is we have this device that can run many, many, many different types of programs, whether it's your web browser for accessing information from online and displaying things from servers all across the world, to a word processor like Microsoft Word, which lets you type up documents, to PowerPoint, which lets you make presentations that you can then show to other people, to spreadsheet editors and so on and so forth. So we have this very versatile machine where you can run programs on it to do many different tasks. So here are some different examples of computers, some of which you might be more familiar with, some of which you might be less familiar with. So a laptop computer is a type of computer. It's a portable form factor. Usually they have a hinge of sorts, so you have a hinge where you can actually open up the screen, and then you have a keyboard and usually some kind of trackpad or trackball or something like that connected to the actual laptop. So it's kind of a all-in-one package. Then you have a desktop computer. This has the actual like physical computer that you set up on your desk, and then you have a separate keyboard, separate mouse, separate monitor or monitors, and so on and so forth. Smartphones also count as computers. They're just computers that run different types of programs than your desktop or your laptop computer. Tablets also are computers. They're just ones that you primarily control them using a touch screen, sort of like what you would with a smartphone. Tablets, sometimes you end up attaching a keyboard and a mouse to, sometimes you don't. Smartphones, you usually don't actually attach a physical keyboard to. You usually use the keyboard that's on the screen. Next up is digital music players. So if you're old-fashioned like me, you might still use a digital music player. I say that like it's old-fashioned. It's not like I'm using one of those old Walkmans or anything like that. But a digital music player like an iPod or one of the newer Walkmans. Sony decided to actually make their digital audio players called the Walkman still. Printers actually have computers inside of them. Those are responsible for receiving data from your computer and then converting that data into instructions for all the components inside of the printer that actually do the printing. Modern day vehicles have vehicle computer systems inside of them. So your car, if you have a newer car, might have a computer that can read sensors within the vehicle. So it might be able to tell you tire pressure, engine temperature, all that kind of stuff. Some of the newer ones also have a GPS system inside of them. So you have a GPS built into your car. If you have a really, really new one, they might also control stuff like the air conditioning or lights or seat heating or something like that. And if you have an extremely new car, they might be able to use microtransactions in order to prevent you from actually using your seat heater until you pay BMW even more money. Yes, this is a real thing. This is probably the future of cars, unfortunately. Robots. Robots are essentially computers that have been given other things. So you might think of a robot arm that can be programmed to, maybe like line up a whole bunch of stuff inside of a box. Like modern day factories will use robots to, let's say, stack cans of soda or something like that into a box that it will then seal up with plastic and then use as like a sort of a bulk storage and carrying thing. Robots might also be more of the robot dog variety, where you have a computer that controls legs and body and whatever attachments are attached to that robot dog, whether it's cameras or guns or anything like that. Modern day pipe organs actually have computers inside of them. What they do is they actually control the airflow through different pipes based on the electronic input that it's getting when you press down on the keys. So it feels like playing a regular piano and, pressing down the foot pedals like you might on a traditional pipe organ, but all of that is being read by a computer, and the computer precisely controls the air that's going through pipes. And many, many, many more. There's many more examples out there. Just about everything has a computer in it nowadays. Your keyboard at whatever computer, if you're using a desktop computer right now, your keyboard probably has a microcontroller in it. A microcontroller is just a really small computer that controls devices. Just about any any piece of newfangled technology. Thermostats now with like the Nest thermostat, doorbells with the Ring doorbell. Your Amazon Alexa is a computer if you have one of those, and I wouldn't recommend having one of those. That's a privacy risk. And so on and so forth. There's lots of computers out there. So when we talk about computers, we usually talk a lot about hardware and software. So the hardware is the physical components of a computer. Those physical components are hard, so hardware. Now there's a lot of different physical components that actually show up in a computer. Ones that we'll talk about to some extent at the very least are the processor, storage, memory, and peripherals. The processor is the actual brains of the computer. So this is responsible for actually running whatever programs you're trying to run on the computer. Storage is where you keep your data. So any of the files that you work with, any of the programs that you install, all those are going to be kept on storage. Memory is sort of the workspace of the processor. And the way we can think about this is if you're sitting down at a desk and you're doing a whole bunch of work, whatever is on top of that desk is you could think of as your memory. You're kind of holding that on your desk while you're using it. Maybe, you have multiple papers that you're currently trying to read through. You're actively reading one of those papers, but you need to keep the other two papers, let's say, on standby so you can reference those papers. So a similar thing kind of happens with the processor, is that it will keep a lot of stuff in memory. It will keep instructions for different programs, and it will keep data that it's currently working with inside of memory, and then it can access any of that at any time that it wants. And then the peripherals are usually the things that you plug into your computer. So a keyboard, one that's not built into your computer if you have a laptop. So an external keyboard is a peripheral. An external mouse is a peripheral. A thumb drive or USB flash drive is a peripheral. If you need to work with CDs or DVDs, you might have an external optical drive. That is also a peripheral. So if you're plugging it into your computer, it is probably a peripheral. And there's more. There's like graphics cards, there's sound cards. We don't really have to get into those. Software is what we call the programs/applications that we actually have on our computer. These are instructions telling the computer what to do. I'm going to use programs and applications interchangeably because they, to some extent, are pretty much interchangeable terms. Applications kind of have a little bit more finesse to them than just any type of program. Applications are usually stuff that you would find in an app store or that you would find on a major company's like website. So like you could probably consider Microsoft Word an application as well as a program, but a first-year computer science student is writing programs that probably are not considered applications. Regardless, applications, programs, they're kind of the same thing. They just tell the computer to do certain tasks. Now, hardware we call hardware because we can actually touch it. Software, we can't actually touch it. So in a sense, we could call it soft. What is software? Essentially, it's really fancy uses of electricity. If you want to learn more, feel free to talk to me about it. There's a whole degree's worth of information that you can really get into with regards to what is data, how do we store data, what are the best ways to store data, etc., etc. You can consider software as being inside of your computer. So when we have an application or program that we're trying to actually put onto our computer, oftentimes we need to install that program to add it to our computer. Installing it is essentially, you get a program installer, and that installer will essentially write the program to your computer so that your computer can then access that program, use that program, all that kind of stuff. So it's putting data in certain places where the applications go, essentially. And then when you want to remove a program from your computer, you uninstall it, and the program will your computer will then go to all those places where the programs live and remove the data associated with that program. So if you want to use a program, if you want to use an application, you install it to your computer. If you want to get rid of it, you uninstall it from your computer. Let's talk about some examples of software. You're using software right now. You are using an internet browser of some sort. So something like Firefox, Google Chrome, Microsoft Edge, Safari, something like that. Or I believe there's also a Canvas app. I don't personally use it, but you might be watching this through the Canvas app, in which case that also counts as software. We will be talking about other software applications throughout this class, namely Word, Excel, Access, and PowerPoint. That's all software. But there's other things that you might not realize count as software. So for example, the mouse pointer is actually controlled by a program. The program reads data from your mouse and interprets that as, the change in position where your mouse needs to go in order to match the movement that you're making with your mouse. You also have a keyboard driver. The driver listens for the keyboard to say something. You press a key and then the driver will say, hey, this key has been pressed. And then whatever, that data gets transmitted to whatever app you're using to type into it, whether that's your web browser or Microsoft Word or something like that. So that also counts as a program, the program that listens for you to press a key on your keyboard and then transmits that data. Another example of software is your operating system. The operating system is the first program that gets launched when your computer turns on, and it is a program that actually controls other programs in your computer. So it handles opening and closing programs. It handles, how much memory each program is taking up, how much space they're allowed to have to store data that they're working with, and the space that is being held for them, to store their own instructions. It also provides the user interface. So the operating system actually is in charge of running those mouse and keyboard control programs that I talked about, as well as the interfaces for any other device that you're using. It will also control stuff like, the desktop. So if you're trying to change your desktop wallpaper or something like that, that is an operation through the operating system. If you're trying to go, find an application to launch through your whatever app launcher you're using, whether that's the start menu or, one of the other various versions of an app launcher in a different operating system, that also is part of the operating system. Your home screen on a smartphone is also part of the operating system. The operating system on your smartphone will display all the app icons, and when you tap on an app icon, the operating system is what decides, okay, so the finger has been put at this position, so I'm going to figure out what that means. Oh, well, that position corresponds to this app icon. Which app is associated with that app icon? Okay, this app right here. So I'm going to actually open this app and display what the app is actually doing. That all is handled by the operating system. So it is probably the most important program that's running on your computer right now. So that is also software that you're using on top of your web browser and mouse pointer software and all that kind of stuff. So here's a few operating systems. There are many operating systems out there. Microsoft Windows, Apple Mac OS or OS X. Mac OS is the much newer operating system that Apple has made. OS X is the older operating system there. The Linux family of operating systems, there's a lot of those out there. There's Ubuntu, Debian, OpenSUSE, Arch, Fedora, and so on and so forth. There's so many out there, so many Linuxes out there. Apple iOS is an operating system. Android is also an operating system. Android started out as an open source operating system that Google then sort of co-opted and started making their own. So there's a Google version of Android, and then there are other versions of Android out there that people have made. And funny enough, Android is actually part of the Linux family. It's based on Linux systems. and then that kind of got forked off a bit into its own thing. Very interesting piece of trivia there. But yeah, these are all operating systems. If you have a computer in your car, that has its own operating system as well. Any computerized device has an operating system, and that operating system might be super complicated. It might not be super complicated. Actually, I shouldn't say any computer system has an operating system, because sometimes there are some like really simple computers out there that you just flash a set of instructions onto, and that's all they do. So like an actual like real big computer is going to have an operating system on there, and that operating system is going to allow you to run programs on there. Now, unfortunately, some computers make it a little bit hard. For example, like a car computer, you can't easily run your own programs on there. That doesn't stop people from trying. People will try to hack into anything and everything, and there's a lot of examples of people being able to do that. I don't know if any of you have seen the somewhat recent, as of the filming of this video, example of someone putting Doom on a pregnancy tester. They were able to do that because the pregnancy tester actually had a computer inside of it, and they had the know-how and the electrical tools in order to actually put Doom on there. So if there's a computer, typically you're able to get your own programs on there, whether the manufacturer of that computer intended for you to be able to or not. Alright, so the next concept I want to talk about is files. So files are data stored on a computer. Now, a computer has a lot of data on its storage, and a file is a cluster of that data that is grouped together into something meaningful. So a file is just a block of data. It's on your computer, and it has an associated file name. That file name gives a name that you're able to reference and say, okay, I know exactly what this file is, hopefully, and the type of the file. The type being, it tells you and the computer what program is needed to actually work with that file. So some example file names right here. The first off is cbiz_101_syllabus.docx. Now, everything before this period right here is the file name, or the name of the file. Everything, the period and after, so the .docx, is the type of the file. Now, the docx type tells the computer, hey, this is a formatted text document. So it has some amount of formatting data. It has a bunch of text in here. In this case, the text that actually goes into my CBiz 101 syllabus, but it also has formatting. So I can put in data about headers, text size, positioning of that text within the document, images, and so on and so forth. The next example right here, 2-1 computerfundamentals.ptx. This is another example of a file name, and this is a PowerPoint file. This is specifically a PowerPoint presentation. This is the name of the file that I am currently presenting off of right now. So you'll notice there's actually 2 periods in this file name. I actually did that on purpose because I want to demonstrate that the file type is all of the text after the last period in the file name. Everything before, including this period, including the stuff before and between the 2 periods, those are all part of the name of the file. The computer will only count the type as everything after the last period in the file. And then here's one more file name, marleysillyface.png. That is a PNG image. That is a certain type of image file type. The fact, I can tell it's a image file because, I happen to know that a PNG is an image. I've just been working with computers long enough to know that off the top of my head. PNG is a specific way of encoding an image. I'll have a brief discussion about that in a second. But yeah, these are 3 examples of file names. So you'll see in here that I have letters and numbers inside of a file name. I also have underscores, like so, periods, and dashes. There's a couple of characters that you're not allowed to actually put in a file name. Slashes and backslashes are illegal. And we'll talk about, we'll see why when we start talking about file paths, but you're not allowed to put those in there. I believe question mark and the @ sign, and there's a couple more that you can't put in there. And it also can vary between operating systems, which characters you're not allowed to put in a file name. And if you happen to put a character that's not allowed in a file name, your operating system will probably tell you, hey, this character is not allowed in the file name. So it will give you some warning. You're not going to blow up your computer by putting a slash in your file name, luckily enough. All right, so here are different types of files that you might see on your computer, and the actual file types that are associated with those types of data. So images, you have JPEGs, PNGs, and GIFs or GIFs. Some people say GIF, some people say GIF. They're referring to this .gif thing right here. So these are all image file types. There's lots more different types of images as well. Actually, for all of these, there are many, many, many different file types for each of these different categories of files. So this is by no means inclusive. But yes, you have your images, JPEGs, PNGs, GIFs. You have audio. Back in my day, we actually used to save our audio as files. So you'll have the MP3 file, or M4A if you're really in the Apple ecosystem, FLACs and WAVs. If you actually ever want to know the differences between any of these different types of files, you're welcome to ask me to go into an explanation, and I'll try to give the best explanation I can. Video files, there's the MP4 file, M4V. M4V is a Apple file type as well. MKV and MOV are also video file types. Documents, you have the good old text file, the .txt file. DocX is for Word documents. .pptx is for PowerPoint, presentations. XLSX is for an Excel spreadsheet. And then PDFs. PDFs are typically used for documents that you're sharing online that you don't necessarily want people to edit, or if you have forms where you want them to fill out specific areas on that form, you'll often see people use PDFs for that as well. So those are super, super common as well. A lot of government forms actually are going to be PDFs. So very commonly used by that. And then programs. Programs actually are files, because if you want to save anything to your computer, you have to save it as save it as a file. So if you want to keep a program on your computer for use, many, many times over, you actually have to save that program onto your computer. So you might see programs that are .exes. Those are Windows programs. .app image, I believe, is you see those on Linux sometimes. You might also see them on Mac OS, but I'm not 100% certain of that. .bat is typically a Windows script, so that's a program. EXEs tend to be applications. .bats tend to be scripts. .sh is a shell script. Those are typically used on Mac OS, OS X, and the Linux family of operating systems. And also, sometimes if you're on Mac OS or you're on a Linux operating system, your program might not even have a file type. It might just be the name. That is a possibility as well. So yeah, these are just some types of files that are out there. All right, so here is an example of some of the files on my own system. So these are all video files. Specifically, they're the video files that I have recorded for this lecture video that you're watching right now. These are all the different scenes that I have recorded for the different slides of the presentation, and this traffic cone looking one is actually the video that I am recording right now. So these are all being displayed in my computer's File Explorer program. Now, a File Explorer actually lets you look at the files on a computer. In this case, I'm using Windows, like the Windows Explorer, which is explorer.exe. On a Mac OS, it's going to be Finder. Apple, iOS doesn't actually have one, interestingly enough. At least not last time I checked, it doesn't have one. Android actually has one. I don't know the name of it off of the top of my head. And if you're using a Linux system, I mean, it completely depends which operating system and which flavor of that operating system even that you're using. So there's a lot of different file explorers out there for Linux. But regardless, this is my file explorer. This is an example of some files. The next thing I want to talk about is file systems. So file systems are the things that actually organize files on a storage device. And these are organized into folders, also known as directories. So you can actually think about it sort of like, a filing cabinet in an office. The storage device that your computer actually holds all of your data on, you can think of as the actual filing cabinet. And inside of the filing cabinet, you have a lot of different folders. Inside of those folders are actual files. So you can follow the structure of folders in order to find the file that you're looking for. And we use the same concept in computers as well. All of our files are contained inside of folders in our storage device, and we can look through the different folders until we find the file that we want. Folders can actually contain other folders or files. So this is a little bit where the filing cabinet imagery breaks down, is that you can have folders within folders within folders within folders, etc., etc., etc. In an actual real-life filing cabinet, we would start running out of room real quick if you're trying to put folders within folders within folders, and that can get a little bit complicated. But when we're not limited by physical space like that inside of a computer, we can put as many folders within folders as we want, and it can be really, really helpful for organization. Now, just like in real life, where you might label a folder with the contents that are in it, folders on a computer also have a name, and we call the root folder we say that the root folder is the highest level folder on a storage device. All right, so I'm back in Windows Explorer, and what I have right here is this PC. I'm at the This PC view. And the reason why I'm here is because I want to access one of my storage devices. Now, in my computer, I have 4 storage devices. Each of these storage devices have their own name, and you can think of this as having 4 filing cabinets inside of my office. I have a lot of different things filed into these different filing cabinets right here. So let's say I want to specifically go into this filing cabinet here, into this one called blah. Now, you'll see the C, D, E, and F thing right here. Essentially, these are labels that the computer itself uses to determine which one of these file systems I'm trying to work with, or that a program is trying to work with, or stuff like that. If you only have one storage device attached to your computer, that's going to probably be the C drive. And the C drive is going to actually be where your actual programs are located. More than likely, you're going to have all of your programs located on your C drive, even if you have other storage devices plugged in right here. The other thing I want to note is that you'll see these are hard disk drives up at the top, whereas this is a device with removable storage. So the hard disk drives are going to be the internal storage devices within your computer, and the devices with removable storage are going to be things like the USB thumb drives. So this actually is a USB thumb drive that I have plugged into my computer right now, and I'm going to open this up. And when I double click on when I double click on this storage device right here, I enter that storage device's root folder. The root folder is the highest level folder of the entire drive. Highest level meaning that it's not really contained within another folder. It's the very first folder that you enter when you go into that storage device. Now, I'm inside the root folder of my storage device called blah, and you'll see that blah has multiple folders inside of it. So this is like pulling open my filing cabinet and saying that there's 5 folders in here. One called Access, one called Excel, one called Experiencing MIS, one called PowerPoint, and one called Word. If you want to enter a folder, you can double click it using your mouse, and you'll end up inside of that folder. And inside of this folder is a single file called cbiz101 syllabus.docx. Now, when you're working with a file system, the location is the current folder that you're in. So in the previous scene, I was in the Word folder. Now the path is the list of folders that you need to follow in order to get to a certain location in storage. My path in the last example, and I'll show it again in just a hot second, the path was my storage device called blah. From there, you click on the Word folder, and that will take you to, well, the inside of the Word folder. So that path will start at the root folder of a specific storage device, and then it will follow that list of folders in order to get to the final location that that path leads to or points to. Okay, so I'm back in Microsoft Explorer, and if you want to see the path to your current location in Explorer, you look up where my mouse is right here. This PC, arrow, blah, arrow, Word. And that gives you the path you can take in order to get back to this current location. So I'll click on this PC, then I'll click on blah, and then I'll click on Word. And I'm back at the same location. Now, if you want to go back up a step in the path, you can click this up arrow, and that will take you back to the previous folder in the path. You'll also notice the back and forward arrows. What the back and forward arrows do is they take you either backwards the way you just came, or forwards the way, if you want to go back forward again. So right now, only the back arrow right here is grayed in, which means that I can actually use it. So if I click back, this will go backwards. So what I did before was I clicked this up arrow. I'm essentially undoing my last directory change by clicking the back button. And then if I want to redo that directory change, I can click the forward button. Now, if I keep on clicking the back button, you'll see me go back along the paths that I took. And if I keep on doing that over and over again, eventually I'll end up in all kinds of other places. And if I'm in the middle of this sort of chain of going backwards and forwards, and then I click somewhere new, I'm going to click on blah again, you'll see that that kind of erases that sort of that path of forwards that I could have taken before, because I sort of broke the chain by doing that. I'm going to do a few more clicks right here just to show off the back and forward arrows. So I'm going to click Access, click back, click Excel, click back. You actually can't see me clicking back, I realize, because I'm doing that with my mouse buttons. So let me do that again. I'm going to click Access, click this up button here, click Excel, click this up button, Experiencing MIS. Now, if I want to get back to Access, I can keep on clicking this back button here, back, 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 and I'm back at Access because I was here previously before leaving Access again. So these are all fun little features that you can use in Microsoft Explorer. So when you're working with files and folders inside of Windows Explorer or whatever other file explorer you're using, there's different operations that you can do. You can open that folder or file And you actually saw me open a folder by double clicking it. When you're opening a folder, you're actually traveling into that folder and you can see the contents of it. When you open a file, you double click that file and your operating system will then figure out which program needs to open that file, and then it will open that program. So that's essentially what opening a file ends up doing. From your File Explorer, you can also create files or folders. You can move them around, so you can move them within another folder. You can copy and paste them, or you can cut and paste them. I'll give an explanation about that in a sec. And you can delete them. Okay, I have the Windows Explorer open again. If you want, we talked about opening folders already, and opening a file would be the exact same. You put your mouse over this file and double click it, and that will actually tell my computer, in this case because it's a docx file, it will tell my computer to open up Microsoft Word. I'm going to head back. If I want to create a new folder or file, what I can do is I can right click and scroll down here to new, or not scroll, but move my mouse down to new. And I get all of these cool options. Now, your computer might have different options than mine, or the lab computers might have different options than mine because I have different programs installed. You probably won't see like CC3 drawing, AutoHotkey script, any of those weird ones. You'll probably see folder. So if I want to create a new folder, I can click here, and you'll see that a new folder has been added. The name, there's this weird box around the folder name, and the name new folder has been highlighted. This tells me that I can actually type in the name of a folder. In this case, I'm going to call it blah. When I'm done, I can either click outside of this area, or I can press enter. I'm going to press enter. And that creates a new folder called blah that I can immediately go into. What I can also do is I can create a new file. In this case, I'm just going to create a new text document. We'll talk about creating new Word documents and stuff like that in the future because there are multiple ways of creating Word documents or PowerPoint or Access or anything like that. I'm going to create a new text document. This places a text document inside of the root folder of blah because that's where I currently am. It places a new text document at my current location. And then I can immediately name it. So I'm going to call this one blah.txt and press enter. And I have a text file called blah.txt at my disposal for me to do whatever I want with. Now, let's say I want to move blah.txt inside of blah. What I can do is I can click on blah.txt in order to select it. You can tell that it's selected because it has this blue highlight right here. It's blue on my computer. If you change some of your settings, it might be a different color, but by default, it is this lovely shade of blue. I can press and hold my left mouse button. So I'm clicking and holding. And then as I move my mouse while I am holding down my left mouse button, you'll see that I'm moving this file around, and I can put it over my blah folder. So I'm holding it over blah. You can tell that I'm holding it over blah because blah is also highlighted right here. And as soon as I release my left mouse button, blah gets moved into blah. Blah.txt gets moved into blah, and I can confirm this by entering blah. Now, I can also move a folder inside of another folder. What I'm going to do is I'm going to exactly the same thing. I'm going to click and hold over blah, and while I'm holding, I'm going to drag my mouse down over Word in this case. So I'm clicking and dragging blah into Word. As soon as I release, blah moves into Word, and as you can see, now Word has blah inside of it. Now here's a fun thing. Let's say I want to move multiple things into Word. Let's say I want to move Access, Excel, and experiencing MIS into Word. I'm going to click on Access, and now I'm going to hold the Shift key and click Experiencing MIS, and you'll see that all three of them are now highlighted in blue. I have selected all three. Now I can click and drag any one of these. It doesn't matter which one. I'm going to click and drag any one of them into Word. And they get, it moves into Word. I can check, and they're all here. Let's say I made a mistake. I didn't actually want to do that. Why would I put Excel and Access and Experiencing MIS inside of Word? If you want to undo a change, there's a couple ways you can do that. You can type Control-Z, or if, I'll admit, I have a modified version of Windows Explorer right here that doesn't actually have the ribbon, but in normal version of Windows Explorer, you'll have a ribbon up here that will have a lot of different options, and the undo option should be under Edit. If I want to undo a change, you can use the keyboard shortcut Control-Z. You press and hold your Control button on your computer, and then press Z, and the folders get moved back out of Word. So I'm undoing that movement. And then if I want to redo it, you can go back to Edit and make that change using the redo key, or you can press and hold Control and press Y, and it redoes that move. So Control-Z and Control-Y are really easy ways of undoing and redoing things. The next thing I want to talk about is copying and cutting files. So what I'm going to do is I'm going to head back into Word right here. Let's say I want to make a copy of my syllabus, and I want to actually put that copy of the syllabus inside of blah. What I can do is I can right-click and move my mouse down to copy. I press copy, and nothing happens yet. When you're making a copy, you're telling your computer, hey, I want another file that has the exact same stuff in here, but I want that copy of the file to be put in whatever location that I paste it in. So in this case, we want to put that copy into blah. So I'm going to go into blah, right-click, and hit paste. And you'll see CBiz 101 syllabus.docx is inside of blah here. And if I go back to Word, you'll see that it's also in Word. So the tricky thing about this is that this CBiz 101 syllabus is a different file than this CBiz 101 syllabus. And I can show this, I can prove it by renaming it test.docx. Test.docx, this retains the original file name, so this is a different file than this. They're completely separate files. I've made a copy of this file. Now, if I don't want to make a copy, if I instead want to move this file, but I don't want to necessarily click and drag it, what I can do is, let's say, okay, a really good reason for me to do this is, let's say I want to move this into the file Experiencing MIS, for example. I'm going to right-click, and I'm going to click Cut, and you'll see, you might be able to see, I'm going to make this icon larger. You can see that the icon is a little bit grayed out, and it has a gray highlight over it when I don't have my mouse over it. This is Windows Explorer telling me that it is ready to cut this file. It is ready to move it to wherever I paste it. So now I'm going to go back to blah, and then go to Experiencing MIS. I'm going to right-click and paste, and now CBiz 101 syllabus is right here. If I go back to Word, CBiz 101 syllabus is no longer here. So when you cut and paste the document, it is essentially the same as moving a document. However, the difference here is that within one single Explorer window, and I'll talk about Windows a little bit more in a little bit. Within one single Explorer window, it's really hard to move a file or folder back up. It's easy to move it down a file structure. It was easy to move a file into blah, for example, but it's hard to move a file back out of blah. So if I come back here to experiencing MIS, this is where CBiz 101 syllabus now lives. So if you want to copy and paste or cut and paste using what's known as a keyboard shortcut, a keyboard shortcut is a combination of keys that you can actually press that do a certain command. So rather than using, right-clicking and using your mouse to copy and paste, you can just use keyboard shortcuts. So for copying, you can type Control-C to actually copy the file, and then once you're at the folder that you want it to be, so let's say I want to put this one in Access, you can hit Control-V to paste it. And you can actually paste a document in multiple places once you've copied or cut it. Actually, once you've copied it, you can paste it multiple times. So I'm going to paste it again in the same place. You'll notice here that I'm getting this error. The destination already has a file named cbiz101syllabus.docx. That's the other thing, is that within one folder, you can't have multiple files with the same name. They all have to have different names. So I could replace it if I wanted to. If it was like an updated version of the same file, I could replace it. I could skip it, which skips the copy entirely. Or you can compare some info just to see if there's like, you're not sure which one's the newer version or something like that. But regardless, I'm just going to skip this for now. So I've pasted it in Access. I'm also going to paste it in Excel by typing Control-V again. And that is a simple way of copying and pasting. Control-C and Control-V. If you want to cut using a keyboard shortcut, you can do Control-X. And I'm going to just paste it up here. Control-V, you use Control-V even if you're cutting. To paste it even if you're cutting. And it's no longer in Excel. So cutting and pasting is Control-X, Control-V. A quick side note about keyboard shortcuts are that they're going to be different across different operating systems. So macOS and OS X are going to use Command instead of Control for their keyboard shortcuts, and the letters that you use for the keyboard shortcuts might be a little bit different than for Windows. So I'm going to give Windows keyboard shortcuts in these lectures if I do give keyboard shortcuts. All right, so the last operation that I want to talk about is deleting. So if I have a lot of different copies of CBiz 101 syllabus, I have a lot of unnecessary files here. They're taking up space on my storage device, and I want to get rid of them. The only copy I want is, well, okay, there needs to be a copy in here, so let me just copy and paste that really quick using Control-C and Control-V. This is the only copy of CBiz 101 syllabus that I want. The way you can do that is by deleting a file. So there's multiple ways that you can actually do this. The first is by right-clicking the offending file and clicking delete. Adios, it's gone. The second, if you go into Access right here, I'm going to get rid of this file by pressing the delete key, not backspace, delete. Now that this is Windows specific, I don't remember what it is for Mac OS, but I know Macs don't usually have a backspace key. They have a key called delete, but it functions the same as the Windows backspace, and it's a whole mess. On Windows, you can delete a file by pressing the delete key. Just like that. I'm going to do the same thing for all the other versions. Oh, there's one more way. I can actually click and drag a file, and if you see my recycle bin right here, move to recycle bin, deleted. I've crumpled up the file, I've thrown it into my recycle bin. Adios. You can also delete folders the exact same way. So I'm going to right-click blah right here, and I'm going to delete that folder. When I delete a folder, it deletes everything inside of that folder. That's gone. Well, not really. Because I can go into my recycle bin, and now here are all those copies of CBiz 101 syllabus and blah. So the recycle bin is a special type of folder. It doesn't work. It's not really a folder in a sense. What it is it's kind of a collection of things that you have told your device that you want to delete, either by right-clicking and hitting delete, or by using the delete key, or by moving them into the recycle bin. And the reason why we have the recycle bin is because it's sort of like a last chance of, like, you can specify a whole bunch of items that you want to delete, and then you can look through your recycle bin and say, okay, do I really, really, really want to delete this? And if you don't want to delete something that's in your recycle bin, you can restore it by right-clicking blah and clicking restore up here. You can also select the items that you want to restore and click this restore the selected items tab right here. And what that does is it actually moves it back to the folder that it was located in. So if I take this blah thing right here and I restore the selected items, then if I head on back to Word, you'll see that the blah folder is restored. It is put back in its rightful place, except I don't want it here, so I'm going to delete it again. Goodbye. Now, things in your recycle bin are still taking up storage space that maybe you could be using for other things. So periodically what you want to do is empty your recycling bin. Like so. Empty it, and poof, it's gone. Adios. And now, at this point, this is unrecoverable. So everything, sort of unrecoverable. That's a fun topic. If you want to learn more, ask me about that. These are sort of unrecoverable now. Probably will be unrecoverable eventually. Who knows? But for all intents and purposes, you can't get those files back through Windows Explorer. So that is how you delete items from your computer, and then actually really delete them from your computer. Alright, so there's a concept called compressed files. So compression on a computer means that you're transforming one or more files so that they take up less space. And that's really about as specific as I can get into it without talking about a whole bunch of crazy math, because there's a whole bunch of crazy math that goes into making files take up less space while still being actual, meaningful data. So when you compress a file, you turn it into something that still holds all the information that you need from it, but not immediately. If you want to actually access the information inside of a compressed file, you have to extract that file or decompress it or uncompress it or whatever back to its original form before you can use it again. So a compressed file, there's a lot of different types. The most common is probably .zip. .tar.gz is another type of compressed file. This is actually a really interesting file type, .tar.gz right here, because this is actually kind of two file types in one. If you want the specifics of how .tar.gz actually works, again, feel free to talk to me outside of this. That is way too technical for this discussion. But compressed files. You'll often see .zip files used to bundle multiple files together when you're downloading them from the internet. In fact, you'll see a lot of .zip files. You'll be downloading them from the internet when we're actually doing some of the MyLabIT work. You'll be downloading some zip files and decompressing them and working with the actual data that's inside of them, which is usually going to be like a Word document or a PowerPoint presentation or something along those lines. And the reason why we typically use compressed files like this, especially when we're sending data over the internet, is that, well, it takes up less space, so it means less data that we have to transmit over the internet. Also, if you're compressing multiple files and then sending all of that over the internet, really, when you compress multiple files into one larger but compressed file, you end up you're only needing to send one file over as opposed to 5 files over, which is, sending one file versus 5 files or something like that is a much simpler operation. Also, you can compress folders, entire folders worth of stuff into one compressed file, and that is much, 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 much easier than trying to send a folder over the internet, because you don't really send folders over the internet. What you would have to do is send all the files contained within the folder, and then just kind of tell the user how to recreate the directory tree, the all the folders within folders structure, and where to put all the files correctly, and it's a mess. So compressed files make things a lot simpler. Now, sometimes programs are a little bit naughty, and they make temporary files. And the temporary files are really helpful for programs, because if they have a lot of data that they're keeping track of, and they're running out of memory and stuff like that, or they need like some really they need to remember certain file paths so long term, so they need to like put data onto a file that they'll promise that they'll delete later. Sometimes they forget to delete those temporary files, or sometimes when you uninstall a program, the program that actually does the uninstalling doesn't catch all the files that were created by a program and leaves them behind, or stuff like that. So a disk cleanup utility actually goes through your computer and gets rid of some of those. So disk cleanup, the program named disk cleanup is a Windows utility program that actually removes excess files from your computer. And this is something that can be pretty helpful to run like once every few months or so. And of course, you got to be careful, because it might affect the performance of some of your applications or something like that. Disk utility tries to be really smart about it so it doesn't destroy everything, but it's not, not 100% guaranteed. But it's helpful, especially if your computer is running a little bit slower than usual. All right, so here's something that the DOS heads in the audience are going to find familiar, and that is the DOS command prompts, revitalized and brought back into Windows. So for those of you who are unfamiliar, this is the kind of way that you used to have to interact with computers back in the day. It was usually something like DOS, or, there's Unix, which was pretty popular for a while. Unix spawned into Mac OS, OS X, Linux, all those Linux operating systems. Android, to some extent, traces its lineage back to Linux. Possibly iOS, I don't know that for certain. Whereas Windows, on the other hand, Microsoft Windows actually traces its lineage back from DOS. Windows actually didn't used to be an operating system. It used to be that DOS was the operating system, and Windows was a program that you ran on top of DOS. So Microsoft ended up decoupling the two. I think by XP, I think Windows XP was the point where Windows actually was 100% the actual operating system. So yeah, you used to only be able to interact with your computer through text. So do you want to see me change into my Alan Hancock CBiz 101 work directory? It's very fun. First, what I would do is I would type in cd, change directories, /d to tell my computer that I have to change storage devices. My work directory is actually on D, so I believe it is. If I have the if I have it right, I don't want to do tab completion right here. For those of you who might be screaming at me about that, I'm not going to do tab completion because I don't want to show off my personal files. So I believe what it is D / documents. Don't spell it wrong. If I spell it wrong, that's a disaster. / work / teaching. I believe it's Alan Hancock. CBiz 101. Hey! First try. And I'm actually going to go into this example folder right here. Now, in Windows Explorer, you can actually see the files that are inside of my folders. And here I have to type in another command called dir. And that, oh, look at that. I have an Excel folder, experiencing MIS, PowerPoint, Word, and Access right there. Kind of a pain in the butt. I mean, you have to memorize a whole bunch of commands. Like if you want to move files or copy files or any of that kind of stuff. If you want to do anything remotely complicated with this, well, it's complicated. You have to memorize all these commands. I'll be honest, I have a lot of them memorized for, for Linux and that kind of stuff, I do not have the command prompt commands actually memorized. I can launch programs, I can move around directories, and that is about it. So people recognized that this was a problem. This was a huge barrier for more casual users. And they said, what if we made it a lot easier? And with that, they introduced the idea of the graphical user interface. A graphical user interface is pretty much the pieces of the computer that you're probably most familiar with. They're built into most operating systems, and they let you visually interact with your computer. So the graphical user interface is the reason why you can actually see your applications. You can see them in Windows. You can use your mouse pointer to interact with your computer. The fact that you can drag files around was a huge revolution in the way that people were using computers. And, scrolling and looking through the folders, all of that were huge changes in how we interacted with our computers, and are pretty much the reason why computers are as widely used as they are now. So the graphical user interface was one of the more important developments in the history of computing. You can also take a screenshot with the graphical user interface. A screenshot saves what you currently see on your screen as an image. All right, so welcome to a view of the Windows graphical user interface. This is my personal desktop right here. I have, and I'll explain that the desktop is essentially sort of like the actual top of a desk when you're working in an office or at school or something like that. This has sort of some of the things that you're working on. So you might have files that you access pretty frequently here, or programs that you need to run. Like I have OBS, a shortcut for OBS Studio. Shortcut meaning that the actual OBS Studio application isn't located on my desktop, but I can click this and it will open OBS Studio right here. OBS is the program that I'm using to record this, by the way. What you'll also see is the recycling bin, just for easy access. You'll notice actually that a lot of terms in computing are related to the office, and that's because when the graphical user interface was being made, they're trying to target it to office workers. So they wanted to make it feel as familiar to office workers as possible, which is why we have folders with the manila folder icon, or blue if you're in Mac OS or OS X. You have the actual recycle bin that looks like a recycle bin, and fills with paper when you put stuff in there, and empties when you get rid of it. But yeah, the GUI was meant to be somewhat intuitive for office workers especially, but just intuitive for users in general. So I want to make a quick note right here. There's this taskbar thing, which shows all the applications I have open on my computer right now. There's actually two. I have two monitors right now. I'm only recording one of them. So Explorer and OBS are open on my other monitor. I can actually drag Explorer between the two, and I can drag OBS. This is going to be freaky. I can drag OBS right here, and you can see the infinitely recursive view of my own desktop. But yes, this is the GUI. The mouse is part of it, this taskbar right here, which by default will actually be on the bottom of your screen rather than on the left side. I just happen to like it on the left side of my screen. Even the wallpaper is part of the GUI. My wallpaper right here is just some relatively obscure video game joke. But that is part of the graphical user interface. File Explorer also is part of the graphical user interface as well. Let me move this over to this monitor and resize it there. So I have opened up File Explorer, and it opens up in a window. The window is this thing that I am dragging around. You can put windows on different areas, like wherever you want on your screen. You can resize them. So if I want to make this window a little bigger, what I'm doing is I'm moving my mouse to the corner of this window, and you'll see this diagonal arrow right here, that means that you can change the size of the window. There's also, if you move it to the right or left side, there's horizontal arrows, means that you can drag them left or right. And there's some for up and down, like so. Another thing you can do is you can maximize a window. So you can click this square button right here, and you'll see a tooltip that says maximize. You click that, and the window just takes up the whole screen, minus the taskbar. The taskbar always shows up unless you tell it not to show up all the time. And then you can unmaximize it by clicking the same button. This time it's going to be 2 squares, one on top of the other. You click that, and you have unmaximized it. You can also snap it to different halves of your screen. The way you can do that is by dragging the window over to the very edge of your screen until you see this like little translucent box show up. And that shows you how the window is going to snap to the left side in this case. And then it also gives you windows that you can put on the right side of the screen. So you can automatically make this one take up the other half of your screen, for example. I'm glad I had the forethought not to show anything embarrassing. Similarly, you can move this window to the right side of your monitor and it will snap to the right side. You can also do upper right half, lower right half, like this. Lower left half. Oh, there we go. Lower left half, like so. And upper left half, like so. You can also use the snapping thing to snap it, or to essentially maximize it by bringing it to the very top, like so. Now let's say you want to temporarily not see this window anymore. You can click this button right here to minimize it, and when you minimize it, it goes away. And whatever else was behind it is still behind it. So let me bring this back up. The way you unminimize a window, by the way, is you hover over the application icon in the taskbar, and then you'll see all of the windows associated with that application. I'm going to click this one, and it comes back. Now you actually have to click it. So when I hover over it like this, it makes it look like it's unminimized, but then if I move my mouse away, it goes away. So I actually have to click it, and it will unminimize, like so. Now the nice thing about the GUI is that you can bring other windows on top of your windows like this, and you can sort of click in between them, like so. Choose them from the taskbar to switch between the two windows. You can also use the keyboard shortcut Alt-Tab. So if you press and hold Alt, your Alt key, and then press Tab, it allows you to switch between the different windows, like so, like so. All right, so having a GUI and having Windows Explorer in that GUI gives us a bunch of really nice features. One really great one is that it makes moving files between very wildly different places in your file structure a lot easier. So what I'm going to do is I have two Windows Explorer windows open. The first has all the videos for this lecture that I'm recording, and the second is the destination file. I want to sort this into my videos folder for all of my CBiz 101 video content. So what I can do is I can take this computer fundamentals video. This is actually the first scene that I filmed for this video that you're watching right now. I'm going to click and hold on it as if I were moving it into a different folder. But what I'm going to do is I'm going to move it into this Explorer window like this. Now, okay, here's the thing. Because this was on my C drive, and I have all of my Alan Hancock stuff on my D drive, it actually counts as copying and pasting it rather than an actual move. So this gets copied over to here because they're on different storage devices. Now, if I were to try to move this over, move it over to somewhere on the same drive. Let's say, what's going to be a safe place for me? Here, I'm going to go to my desktop. Let me delete this real quick. I'm going to go to my desktop. Oops. Right here. There we go. I'm going to make a new folder called law. Now, my desktop is on my C drive, and my videos folder here is also on my C drive. And if I move this from here to here, because they're on the same storage system, it's going to actually move it over as if I was moving it moving it to a folder within the same folder right here. So you can actually move between folders using multiple Windows Explorer windows, and you can actually make this easier by snapping it to the left and right side. If I want to move it back, I can just do this. And there we go. It's that easy. Now let's take a look at closing a window. That's very easy. If you have a window or an application that you're not using anymore, hit this red X, and it's gone. And this actually brings me to the last thing that I can show off, which is moving a file to the desktop. You can do it just like this. And now it's on the desktop right here. And I can actually put it anywhere that I want to on the desktop. You're able to move this anywhere that is most convenient for you and your sorting system. Now, it usually snaps to a grid. I believe you can disable that if you want to. Personally, I don't even really use my desktop, so I don't necessarily keep files on here, except for like OBS Studio. But, that option is available to you. Alright, so really quickly, I want to talk about backups. You can make a backup of your computer, and that will essentially save all of your files, your programs, your settings. It also saves your directory tree on all of the storage devices that are on your computer. So typically these backups are going to be highly compressed. They're not going to be accessible for you, so you're not going to be able to actually access the files that are on your backup. But what they do is it's sort of like saving the current state of your computer. And then if something really bad happens to your computer in the future, well, you have that backup that you can then restore from. So either you can, maybe you deleted a really important file and you want to restore from a recent backup so that you can get that file back. Or maybe you made a backup of your computer and then your computer got into a catastrophic falls into a concrete mixer accident or something like that. Then you can typically restore another computer from that backup of your old computer, and then you have access to all of your data again. So backups are really helpful. They're good to have. Highly recommend making backups frequently, especially if they're backups that aren't stored on your actual computer, but are stored on some sort of external storage device. All right, so now let's talk about updates really quick. Oftentimes, developers will improve their programs after release, so that will release a program and then maybe come up with a new feature, or maybe they'll come up with a patch for it because they shipped something, they shipped their program and then their program actually was broken in some way, so they have to patch it or fix the sort of programming hole that they left in. Or they need to make a security update because they didn't realize that something that they coded in actually leaks user information or something crazy like that. So they have to fix that issue so that the user's data doesn't get compromised or their computer doesn't get compromised or something like that. So they will release an update so users get those changes, and then the users will update their program. There's different ways of updating your programs. It depends on if you're updating an application or updating Windows itself, or whatever operating system you're using. Typically, the applications themselves, if you have a more modern application, like one of the really fancy ones, you'll be able to update those within the app itself. Sometimes you have to download the newest version of your program from the programmer's website. When it comes to Windows, you have to update that through the Settings app. And actually, the simulation training will show you how to update your computer. So keep an eye out on that. The next brief topic is Cortana. So Cortana used to be a video game character. She used to be Master Chief's best friend, only friend in Halo. Now she is a virtual assistant, sort of like how Siri is the virtual assistant for iOS devices, for your iPhone or iPad. Alexa is the virtual assistant for Amazon devices. And I don't know what Google calls theirs. Like you just say, "Okay, Google." So I guess Google is the Google virtual assistant. I don't know. It's kind of weird if you ask me. But regardless, Cortana is the Windows 10 virtual assistant. You can use Cortana to search for files, to provide recommendations. You can say, "Hey, where's a cool restaurant near me?" And sometimes Cortana works. You can also use Cortana to set alarms on your computer and stuff like that. All of this stuff you can do manually yourself as well. Cortana is meant to make it easier for you to do that. I remember when Windows 10 was first released, and Cortana was like a new feature. It was not any easier, but it's easier now. I'm sure they've improved Cortana. I just do all that stuff manually myself, so I don't know much about her. But there's a little bit that you'll be able to do with her in the Windows 10 simulations on My Live IT as well. All right, this last section of the video, I promise we're almost done. The last section, I'm going to talk about bad things that can happen to your computer, and how you can possibly try to mitigate those bad things a little bit. The main topic here is going to be malware. Malware is any program designed to do bad things, and there are lots of different types of malware depending on the exact way they go about doing the bad things on your computer. There's viruses, there's Trojan horses, worms, ransomware, keyloggers, adware, spyware. They all have their own functionalities. They all have very interesting cases, very interesting examples, and I'm happy to go into any of these in more detail if you are interested. But that, again, is beyond this very simple discussion. So there's a lot of different types of programs that can do harm. Now, luckily, there are ways you can try to help protect yourself against malware. There's anti-malware / antivirus software. Nowadays, the terms get kind of used interchangeably. Windows Defender is built into Windows 10, and that will help try to detect bad programs on your computer and stop them from working. There's also programs like Malwarebytes. There's Kaspersky. There's McAfee, which don't use McAfee. I think it was either McAfee or Norton that were like the antivirus virus, quote unquote, because they're just impossible to get rid of and really annoying. One of those two. Don't use either of them if you ask me. Windows Defender does a pretty decent job nowadays, but you'll want to get something better for yourself eventually. Kaspersky and Malwarebytes are ones that I've heard recommended as being pretty decent. There's also firewalls. Firewalls are programs that monitor the internet connections that are going out of and coming into your computer. So if people are trying to access your computer to do weird things to it through the internet, a firewall is going to stop that, so you don't get someone like trying to log into your computer remotely and install a weird program on it, or steal all your data, or monitor what you're doing on your computer, or something like that. So there are anti-malware and firewalls are usually the two biggest things that you're going to do in order to prevent bad things from happening to your computer. Of note is that Windows Defender actually has a built-in firewall as well. Now, here are some things that don't 100% stop malware. You might have heard that there are no viruses for an Apple computer or an iPhone or something like that, and that is just plain not true. There are far fewer malware programs for Apple devices than there are for Windows devices. But that's more of a factor of what Windows devices are being used for and how many people are using them. Notably, the government uses Windows computers primarily. So you're going to see a lot of viruses specifically because of that. Also, there are just a lot more people using Windows computers than Apple computers. It's why we're teaching Windows right now. So you'll see a lot more viruses targeted for Windows because they're just going to hit more people. Also, a lot more businesses use Windows purely because it's a lot cheaper to get Windows computers like in large quantities than Apple computers. Because Apple computers tend to be marketed towards like, hey, you're doing something really crazy, like music production or something like that, and you want an expensive machine for that. Whereas Windows devices are like, yeah, here's a $200 computer that can run Microsoft Word, have at it. So because a lot of businesses are using Windows computers, you'll see a lot more malware written for Windows because of that as well. Using a VPN, there's a lot of VPN ads that tout, how safe they'll make you, and they really don't do that much for safety. They're really only helpful if you want to change your IP address, if you want to make it look like you are not accessing some website from where you're actually accessing the website from. So if you want to say, I want to make it look like I'm accessing this website from Germany instead of Santa Maria, California, that's what a VPN is pretty much best for. I think the other biggest reason is if you don't want the internet company, the company that is providing you internet to see what you're doing, then you can use a VPN. But then, of course, the VPN company can still see what you're doing anyway. So you're kind of trading one thing for another. So using a VPN, a VPN does nothing to stop malware anyway. If you download a bad program, the VPN doesn't stop that because you're still downloading it. And then having antivirus software, it will help a lot. Antivirus software helps a lot in mitigating most problems, but it's not 100% guaranteed. Especially, if a new development is made. Bad people are always trying to make new malware. So, a anti-malware program can be on the cutting edge, but that's only, that only is so good. And even then, even if it's an existing program, an anti-malware program is looking for signs and symptoms that there might be malware, but it's not 100% guaranteed. It would be impossible for it to be 100% guaranteed. So really, the best thing you can do is to be careful. And here are some ways that you can be careful. Do not ever plug in random USB devices that you find. If you see a flash drive on the ground in the middle of school, don't plug that in. Take that to, the lost and found, which is, I believe, campus security. You would go to campus security and say, hey, I found this on the ground. Hopefully they also don't plug in a random USB device to try to figure out who it belongs to. They might, but at least it's their problem and not yours. If you log into an account on a public computer, log out when you are done. This is less of a malware problem and more of a, you don't want people getting access to your Facebook account or your email account or your My Hancock portal. My Hancock portal could be especially devastating because someone, imagine someone dropping you from all of your classes and then you lose financial aid or something like that. That could be really bad. Canvas and MyLab IT, you'll want to log out of, you want to make sure that you're logged out of your My Hancock portal, Canvas, and MyLab IT if you're working on the classroom computers or if you're working on one of the computer lab computers. Anything you log into when you're on a computer that you do not own, log out of immediately when you're done. You can consider using a private browsing mode like Chrome's incognito mode or Firefox's private browsing mode. You can usually find those under File and then New Incognito window or New Private Browsing window or something like that. But those will actually, when you close a private browsing window, it actually does not remember that you were logged in. to that service. So it is completely safe to use a private browsing window. It's completely safe in terms of it logs you out when you are done, and it is not safer in terms of like account security or network security or something like that. You should only download software if you are sure it comes from a reliable source. So I gave you instructions on how to access Microsoft Office, and in that case, I would hope that you see me as reliable. I understand if you don't. That's totally fair. But at the very least, those instructions also came from Allen Hancock themselves, so hopefully you also see them as reliable enough to trust for download instructions. Or the actual Microsoft Outlook website where you download the installer from, that would be a reliable source. When in doubt, you can check the URLs to make sure that, hey, this is actually the Microsoft Outlook website. Or if you're downloading Chrome or something, you can check to make sure that is the actual google.com website. If you see some fishy website like google.xyza that has a Google Chrome installer that's like, install this important security update right now, don't do that. That is probably going to be a virus. Also, don't open random links sent to you, even if seemingly from a friend or a trustworthy company like Google or something like that, especially if it's accompanied by a scary message like, your account is going to be deleted in 5 seconds if you don't click this account recovery link and sign in immediately. Because that is probably what's known as phishing, where someone poses as someone you know or a website that you have an account with or something like that in order to try to get you to enter your account information. Another thing might be like, we're withholding your pay unless you enter your account information, or your storage is full and we're going to delete your school email address or something like that. This is especially true for your Allen Hancock email address. For whatever reason, school emails seem to have a lot of phishing attacks on them. It happened to me when I was a student at Cal Poly. A lot of people fall for these phishing links, and then they get their accounts logged into, and they start sending phishing emails. So it looks like it's from a legitimate person, and that's a bad thing. So same thing can happen on messaging services. This was a huge problem with like Skype back in the day, is someone would send you a link on Skype and be like, hey, have you seen this? Nowadays, it might be like a DM on a social media app or in Discord or something like that, where they're like, have you seen this call out about you? I gotta block you because I can't be associated with someone who has done all these crazy things. That's probably phishing. So be very careful about that. But that's my phishing rant done with. Just be careful out there, It's a dangerous place. And technology can be used for bad things. It's used for many, many great things, but of course, it can be misused. Anyway, that is my super long talk about computer fundamentals. Most of my lectures after this are probably going to be a lot shorter. It just felt more apt to fit everything regarding computer fundamentals into one big long video that you can access when you need to. So all the basic information is contained in this one big video, if you ever need to look back on it. Thanks for sticking with me.